So let's say we started with y equals arcsine of x. If this is an inverse trig function, that means that sine of y equals x, right? That's the definition of inverse sine or arcsine. Yes? Are you with me? Yeah? Yeah? Okay, no? Nobody? Okay, let's draw a triangle. And it says find cosine of y. So here's my right angle. Y is my angle, right? Yes? Mm-hmm. Okay, so we'll make y here. And then this is x over 1, let's say, right? X over 1. Okay, so x sine is opposite. X over hypotenuse. 1. Are you with me? Yes?
Yes.
Okay, cool. And then how do I find this side? Yeah, this is square root of 1 minus x squared, right? Okay, so cosine of y is adjacent over hypotenuse, square root of 1 minus x squared. All right, does that make sense to everybody? Yeah. Yes? Okay, so now if I take the derivative of this, what do I get when I take the derivative of sine y? Cosine y, then what? Dy dx, right, because I took the derivative of y equals 1. Okay, so dy dx is equal to 1 over cosine of y, right? And we found out cosine of y from our right triangle. So that's 1 over square root 1 minus x squared. Okay? That is the derivative of arcsine x. Okay? And you can do it for all the other trig functions if you want to, but you would end up getting these 6 down here. Okay, so the derivative of arcsine x is 1 over root 1 minus x squared. Cosine is the same as sine, only negative, just like normal derivatives. Tangent, do you want to do tangent?
Sure.
To prove it?
Sure.
Okay, sure. Okay, so this is y equals arc tan x. Okay, so that means tangent of y equals x, right? So now we draw our triangle here. Oh, you can't see it, sorry. So here's the right angle, here's y is our angle. So tangent is opposite over adjacent. X over 1 here. So hypotenuse, our hypotenuse would be square root, no.
The square root of x squared plus 1.
Yeah, square root of x squared plus 1. Cool. And then we take the derivative of tangent y and we get dy dx, right? Equals 1. What is secant squared y? So secant is hypotenuse over adjacent, right? But then squared would just be x squared plus 1. And so dy dx is 1 over x squared plus 1. And that's how you get arctan. So that's why the root disappears, because you have secant squared for tangent. Any questions? Secant and cosecant we could do, and cotangent, if you wanted to, is just the negative of tangent. The only ones that you really need to remember are sine and tangent, because those are the only ones that are tested on the AP exam, although I would like you to know cosine. Just because. Cosine's the negative of sine, so it's not hard to remember. So just know sine and tangent. You don't have to use cosine, but I would like you to know the derivative of cosine is just the negative of sine. Here's how I remember it. Like the sine, arc sine, starts with an S, right? So that's the one that needs the square root. And then arctan x, that's the one that starts with a T. So this one has a plus sign because it's S-I-G-N. Because it has a T so the T is plus. That's how I remember which one should be plus and which one should be minus. And which one should have the root and which one should have the root. But you don't have to memorize that. If you can just memorize the formulas, then you don't need it. Okay, so if we're going to take the derivative of these, you just do normal old derivatives, but now you know the arc sine of something is 1 over square root 1 minus, okay, then it's the inside, so this x squared goes inside of this x squared squared. So simplify, and then I have to multiply by the chain rule, derivative of x squared, which is 2x. So if we simplified it, you would get 2x over square root of 1 minus x to the 4th. Okay. This one, x squared, tangent inverse of 3x, the derivative, we'll have to do product rule. So it's first, derivative of a tangent is 1 over 1 plus quantity 3x squared times 3. First times the derivative of the second plus 2x, and then tan inverse of 3x. Yeah, we can just leave that like that. So really the only really simplification we could do is this 3x squared goes on top of this.
And make it 9.
Yeah, and make it 9x. Okay. Got it? Alright, so derivatives of inverse trig, not that hard. Integrals always gets more annoying than derivatives. So you just need inverse sine and inverse tangent. The reason why they don't do inverse cosine for this one is because the cosine formula is this, right? Yes. So if I just pulled out a negative from the integral, I could make this into an inverse cosine. The AP people don't want to do that, right? They just want to give you one option for what it could be. So they just make it inverse sine, so that you only have one option for the inverse trig function, not two options. Because technically, you could make this into an inverse cosine if you wanted to. Okay, so all you have to do is remember inverse sine and inverse tangent. There's inverse sine has the one, no 1 over a in front, inverse tangent does. I can explain what's going on there, or you can just memorize the formula. So we'll do a couple examples of that so that you know what to do. Okay, 1 and 3 are easy. This you should just recognize is what? Sine inverse, yes. Of x plus c. 3 is easy. It's just tangent inverse of x plus c. Okay. But all the rest are not as easy. Let's take a look at number 2. 2, if you use the formula, this would be 1 over square root 4, or square root 4 minus x squared. So this should be equivalent to, if you just memorize the formula, sine inverse of u is x over a is 2, and then plus c. So if you memorize the formula, then it's pretty easy, as long as your u is something nice. If you don't, this is essentially what you're doing. The mathematical process is to factor out a square root 4. If I take out a square root 4, what's left in my root? 1, right? 4, take out the 4, minus x squared over 4, right? Yeah? Are you with me? Yes? Okay. Then this can be a u sub problem. U equals x over 2, right? du is 1/2 dx. So dx equals 2 du. And if I rewrite my integral, it would be integral. I'm going to pull out the 2, but I'm also going to pull out the 1 over root 4. And then this becomes du over root 1 minus u squared. Okay. So what do the 2 and the 1 over root 4 do? They end up canceling each other out, which means that this is just inverse sine of what u was, and u was x over 2 plus c. Okay, so that's why this is the integral.
Do we ever need to do anything?
No, if you just want to memorize the formula, then just memorize the formula. But this is mathematically what's happening. I just wanted to tell you.
Thanks.
Yeah, no problem. Okay. 4, do you want me to do it the long way, or do you want to just do it the short way? You tell me. Short way? Okay. This is an inverse sine, right? What is u and what is a?
U is the square root of 2x.
Yeah, u is x root 2, right?
Oh, right, yeah.
Let's do it that way. And then a is the square root of 5. Everybody see that? Yes? Okay, now be careful, because in this case up here, our u was just x. So we didn't have to do anything. But if our u is something other than x, we're going to have to do a du. What's our du? Just root 2, right? dx. Okay, so when we do our inverse sine, we have to do divide by root 2. Okay, so we have to write our inverse sine with a 1 over root 2 to take care of our du part. 1 over root 2 inverse sine of u over a, x root 2 over root 5 plus c. Does anybody have any questions on that? No?
Wait, why did you just take it out?
This 1 over root 2?
Or, I guess, just the root 2. Like, why'd you find the u?
Oh, because u wasn't just x. So if this was just 5 minus x squared, then I wouldn't have to pull out like the divide by the du. But remember when we were doing the trig problems on delta math, and we had to, like, every time we had a u that was a linear, we had to divide by like the derivative, right? It's the same situation here. So like my u is something other, is a linear function, so I have to divide by the du part. Okay, so let's do this one again. U is what is u? Oh, same thing. X. No. This is not a problem we can do. Why?
Is it tan?
It's not tan,
Oh, because of negatives.
because it's a minus. So let's change this to a plus, because I haven't taught you how to do partial fraction decomposition yet. So let's change it to a plus. So yeah, so that you can, we can actually do it. You learned it last year, or in pre-calc. You just haven't used it yet.
I still don't get it.
You're gonna, you'll
I
have to get
remember
it.
I learned it, and then I forgot it.
That was great. I was reading pre-calc tests, and then I saw them. I like no doubt already. No doubt.
Okay, so we have a du for this one too, because our is x root 2, so du is root 2. So we have to divide by that on the outside, but we also have to, for inverse tangent, we have to divide by this, the a as well. So I can do the proof of that, but I'm not going to right now. So 1 times 1 over root 5. So this is our u sub part. This is the 1 over a, and this is tan inverse of u over a. So x root 2 over root 5 plus c. Okay. Any questions on that one? Okay, number 6 is a good one. But we will need more space, so let's bring it down here. Okay. Now, if I were to start normal u sub for 6, I would think, oh, let me make u 4 minus x squared, right? And what's du? Negative 2x dx. But then I look at the top here, and I don't just have an x, I have an x plus 2. So that's not going to cancel, right?
Oh.
Yeah, oh, is right. So what should we do instead? No, I haven't taught that to you yet. But you can divide it up into 2 separate integrals. Yeah. Right? So we can do 2 separate integrals. This part right here, let's solve the first part. This one right here, I can do u sub 4. Negative 2x dx. Okay, so dx is du over negative 2x. So my integral for this one will be integral of x over root u, and then du over negative 2x. Beautiful. My x's cancel. And then I just have to integrate negative 1/2 u to the negative 1/2 du. Integral of that is u to the 1/2 negative. Are you with me? So that's that part, right? I think it stays negative because you add 1/2 and then you multiply by 2. Okay, that's that part. That part's done. This one is, if we integrate that one's an arc sine problem, yeah. We'll leave the 2 out, so the integral of 2, 1 over square root 4 minus x squared dx. Okay, so we'll leave the 2 out of that one. And then, what's my u? Just x. What's my a? 2. So this would be, so if u is just x, I don't have to do u sub. This will be 2 times, does sine inverse have the 1 over a? No, it does not. Sine inverse of u over a, x over 2. And then we combine it, combine these two. So this is equal to negative root 4 minus x squared plus 2 sine inverse of x over 2 plus c. How fun was that? So fun. Such a great time. Okay. So that's inverse trig. Yeah. This one? No, I won't go that bad on you. Not till later. Unit 7.
We'll be learning different technique for doing that.
Where you, huh?
We'll be able to technique for doing that.
When you learn unit 7, I can throw in like multiple different types of integration. Unit 7 is techniques.
Right, the different techniques of integration.
Yeah, by parts, partial
Right.
fraction,
Oh, yeah.
inverse trig, completing the square. Okay. Okay, guys, are you ready for some L'Hopital's rule? Okay. So, L'Hopital's rule is, we're going back to limits now. It's L'Hopital, but it's like different people write it with an S, and then some people don't write it with an S, and then some people write it with the O and a little hat. What's that thing called?
The
It's
hat.
in French. What's that thing?
It's no hat.
Is it O
I know
hat?
it as a hat
P
for
hat.
vectors.
Oh, it's a
Anyways,
hat.
but some people write it like that. Okay, L'Hopital's rule basically says that if you have an indeterminate form,
Every sentence.
0 over 0, then the limit of f of x over g of x, because 0 over 0 usually means you have a, what? Well, yeah, it is an indeterminate form, but usually it means you have a whole. No. Asymptote is a number over 0.
Oh, the circumflex, if you were wondering.
Circumflex?
Yeah.
What, a hole?
No, the little hat. The hat.
Oh, circumflex is a hat. Okay, so 0 over 0 means you have a hole
Okay.
most of the time, and if you have a hole, then the limit exists. Before you were asked to factor it, right, and then cancel out the hole, and then you found your limit. This way, if you use L'Hopital's, what they say is, if you take the limit and you get an indeterminate form, but only if you get an indeterminate form, then if you take the derivative of the top and the derivative of the bottom, then you can find your limit that way. For example, like, remember when we had limit x goes to 3 of x squared minus 9 over x minus 3, right? And you plug in 3 and you get 0 over 0, yes?
Yes.
Yes? And then you said, oh, if I get 0 over 0, what should I do? Factor it, right? So this becomes x minus 3, x plus 3 over x minus 3, and they cancel, and then you plug in 3 and you get 3 plus 3 is 6, right? and that's, and your limit is 6. By L'Hopital's, what L'Hopital says is, if you get 0 over 0, then I can go here and I go limit as x goes to 3. What's the derivative of x squared minus 9? 2x. What's the derivative of x minus 3? Just 1. And then if I plug 3 in, what's 2 times 3? 6. You get the same answer. So L'Hopital's is a little bit easier, especially when you start working with trig functions in your indeterminate forms, because trig functions you can't factor and cancel. You have to use L'Hopital's. Okay?
If your derivative over your derivative is equal to 0 over 0, and that too is an indeterminate form,
You can do it again. You can, keep doing it. Yes.
Does it only work for indeterminate?
Yes. Yeah, good question. It only works for 0 over 0, so if you are using L'Hopital's on the AP exam, then you have to prove that it's an indeterminate form in order to use L'Hopital's. They won't give you credit if you don't do a proof of it. Okay? So, the reason why, here let's do like a short reason why. Let's start with f prime of a over g prime of a. You don't need to know this, but this is like the reason why it works. If we were to write both of these in definition of a derivative, then I can go limit x goes to a of f of x minus f of a over x minus a, right? That's the derivative of, that's what f prime of a equals, right? And then if I do the g prime of a, that's limit as x goes to a of g of a minus, g of x minus g of a over x minus a, right? The x minus a's are the same, so they can cancel out. So what I have is limit as x goes to a of f of x minus f of a over g of x minus g of a. Right? Now, this is only going to equal limit as x goes to a of f of x over g of x if f of a and g of a are both what?
0.
Right. So you can only use L'Hopital's if you get an indeterminate form for f of a and g of a. So that's why we have to prove that f of a equals 0 and g of a equals 0 in order to use L'Hopital's, because this is only going to work if both of these are 0. Okay? That's why you have to do the proof before you do it. Okay, so let's do a couple examples. First, when you're doing these, oh, also it works for infinity over infinity because it ends up being 0 over 0 again. So infinity over infinity is another indeterminate form. So for when we're doing these, the first thing I want you to do is do 0 squared. And what's 0 squared? No, not 1. 0. And then 2 times 0 squared plus 5. What does that equal? 5. So do you get 0 over 0? No, we don't do L'Hopital's. And what does this limit equal? Yeah, 0, because 0 divided by 5 is 0. So we don't use L'Hopital's for this one. Okay. If I plug in 0 in the top here and I go 2 times 0 squared plus 5, and you have to do both the top and the bottom if you're going to use L'Hopital's. This is 5, right? And 0 squared is 0. Then I have a 5 and a 0. Can I use L'Hopital's? No. So 5 on the top and 0 on the bottom. What does this limit equal? Does not exist, right? Because you got an asymptote, not a whole. All right, number 3. should I use L'Hopital's for this one? We're going to infinity, so remember, we're looking for which one gets bigger. Does e to the x get bigger or 3x squared get bigger? E to the x gets bigger, so we don't need to use L'Hopital's for this one. We're going to know that that automatically goes to infinity because the top is bigger. If the bottom is bigger, what does it go to?
Yeah.
What?
0.
0. Good. Okay, let's do 3. So you want to go 3 times 2 squared minus 7 times 2 plus 2. What do we get there? 0. And then 2 minus 2 is 0. Are they both 0?
Yes.
Yes. Okay, so then we can do L'Hopital's and we can go limit as x goes to 2 of, and then what's the derivative of the top?
6x minus 7.
And the derivative of the bottom is 1. So now we can plug in 2 and we get, okay. It's nicer than factoring. Okay, let's see if I can do L'Hopital's for 4. So we do 3 plus 3. Remember, you have to show this. Oh, no, 3 plus 3 is not 0. 6. And then we do square root of 3 squared minus 5 minus 2. That is 0, right? Yes?
Yeah.
Okay, so 6 over 0. Do I do L'Hopital's?
No.
No, I just say that this limit does not exist. Okay. You have to show these two things if you're going to use L'Hopital's. So make sure you show them. Okay. I want you to try, so now we've got trig functions in because you can't factor trig functions. Try, 6 is obnoxious, so don't do 6. Do 5, 7, 8, 9, and 10, and see if you can get those.
Just one.
Yeah.
So we don't have to prove like the special cases for does not exist. Like we don't have to prove that they're both going to infinity.
So you will once we get to those special cases, but we are not doing special cases this unit. This unit, I'm only going to give you 0 over 0 or infinity over infinity. So prove that the top goes to 0, bottom goes to 0. We're going to do special cases in unit 7, I think. So you're not going to get a standards quiz on L'Hopital right now. Your standards quiz on L'Hopital will be later. We're just learning L'Hopital right now so that you know it. Okay. All right, try these problems. Let's see what you can do. Yeah,
Keep on doing it.
you can keep going.
That's driven himself for a while.
You can, yeah, if you keep getting 0 over 0, then you keep doing L'Hopital. Okay, so this is what I got for 5. Did you get 5 right?
Do we have to simplify fractions?
No.
No.
I mean, on multiple choice, yeah, for sure. 7 and 8. 8 was really gross. But make sure you're, like, showing that the top equals 0 and then the bottom equals 0 before you do L'Hopitals. I can't stress that enough because they really want to see that. Okay, so I did product rule for the first part. Derivative of cosine is negative sine. So that one just straight up equaled 0. And then 8 was annoying. The first L'Hopital was secant squared minus 1 over 3x squared. Then if you take the derivative of secant squared is 2 secant x times secant tangent over 6x. And then the bottom was even grosser. Any questions on that?
Wait, if you get the right answer but you don't like do correctly, will you take off points?
It depends on, I mean, honestly, it depends on how hard I'm looking at it, you know? Like if it's free response on a test, I'm looking at every step. But if it's like if it's like a standards quiz, probably not. Okay, and 9 and 10, just looking at it, because I threw in some infinite limits, you could do these by L'Hopitals, but it's actually easier from what I taught you a while ago, was you look at whether the top or the bottom were higher, lower, or the same, right? These have the same degree. It's x cubed for both of them. So it's leading coefficient over leading coefficient for this one. But remember to cube the 2. And then for 10, the top is smaller than the bottom. X to the 5th goes to infinity faster than natural log x. If you don't know which one does, think about the graphs. The graph of x to the 5th goes like to infinity, but the graph of natural log x is looks like this. So it can't go to infinity that fast. So the bottom's bigger, and when the bottom's bigger, it goes to 0, right? And then I threw in a little bit of like which to know, which one's bigger and smaller. Like natural log x is the smallest, x to a degree is bigger, and then an exponential is the biggest. Okay? All right, so that's L'Hopitals. You're not going to have a standards quiz on L'Hopitals, just on inverse trig, derivatives, and integrals next time. And do the homework if you need some